Yo, yo, yo. Good morning, everybody. Devioli, if I knew early you were on Twitch, my life would have been easier. Yeah, I've been streaming on Twitch for a while, and that's usually how it goes. I stream to both YouTube and Twitch, and then people can choose where they like to watch. What's up, DDG and Harukan, good morning. And Darabo, how nice to see your name in chat again. And Toffai on YouTube, what's up? So, I begin today's stream with this Wikipedia page because this is what we're gonna do today. Let me just summarize why. Good day, I'm me. What's up, Wolf C? What's this? Yeah, midpoint circle algorithm. It's a very nice algorithm. Mainly used to correct rasterization of circles. Really nice to be watching again. Nice to hear. So, what we're working on right now is terrain and the art of terraforming. And so the idea is that we mark the terrain, we have this circle marker, and then we want to be able to heighten or lower the terrain here. And I guess the most straightforward way would be to just change this circle into a square and change all the pixels within that square. That might be easier, more straightforward. We're going to implement that route too and compare the two. What I maybe foolingly started with, however, was to try and just change the pixels within the circles, because that's actually the only vertices we want to change, and to properly calculate which vertices those are in a nice fashion. We're going to use midpoint circle algorithm, because although we're not working with pixels, we're working with terrain vertices, which can in some ways be seen as pixels. So that's what we're going to do. Wolf A, the YouTube stream is a little bit slow. Oh, that's not good. Like, is it delayed or is it lagging? Devioli spent 12 hours yesterday to get a final grasp on how the outlines work and try to fix my approach. In the end, I had to give up and use your version. I just couldn't get the occlusion running as I wanted. Yeah, I get that. Like, truth be told, I spent a great amount of time on that outline shader, and I've also spent a lot of time after the public release. So the one I'm currently running in my game is quite a bit different from the one on GitHub, but hopefully the one on GitHub works for you. Derabo, is the landscape using marching cubes? No, I made a decision pretty early on that I don't want to support... Okay, let me put it this way. I made a decision, but I'm still second guessing myself. But I made the decision that I don't want to support overhangs or caves and stuff like that in my terrain. We're just going to go the simple route of a plane, basically, with a height map. So no marching cubes as of now. It's just a simple height map, and then we offset the mesh depending on the height map. Wolfie, yeah, delayed by a sec or two. Twitch is way better. Yeah, I might want to look into that. So currently I'm running OBS version 30.0.2, and I don't support multicasting straight out of the box, so you will have to rely on an add-on, and yeah, I don't know, maybe something. So it could be the add-on that has a little bit of a delay, or it might be on the YouTube side, I don't know. Could I escape back to Circle? Yes, indeed. Oh yeah, that saves a lot of pain, I think. Good decision. Yeah, I hope so. I want to get something up and running. Yeah, like for this, at this time I didn't really look into marching cubes too much. I knew what it was, and I've read some white papers way back about it. White papers, I think it was in GPU Gems where I first read about marching cubes terrain. And yeah, didn't want to have to deal with that basically. We touched on the decision yesterday as well. And although like allowing for a marching cube terrain and caves and stuff like that opens up a lot of fun gameplay mechanics, it's also something I don't want to spend too much time on right now. So anyway, midpoint circle algorithm. I think we started implementing it yesterday, and we have something to say the least. So we have something like this. We have a current bug in our system, but that's because I tried to jump over some steps and implement it in a way that would work better with what we want to use it with. But seeing a result like this makes me think that I might want to take a step back, implement it the original way, and then we can start altering it, right? Good morning, Geralt. So, I'm pretty sure this is the part that screws it up. So we got... Oh, actually... It's not. Okay, let's take a look at this. So yesterday we got one... What do they refer to it as? Let's see. Yeah, first octant. So they split up the circle in 8 parts, and then they loop through the algorithm for all those 8 parts. I started by merging them, and yeah, it didn't go as planned. So I'm gonna take a step back, implement one octave or octant as a function, and then we should be able to call that function 8 times. And hopefully get the full circle. So we have get next point, angle check, coordinate check, and get radius error. Let's do private. Maybe let's just do it as a void and draw octant. And I think we want to send in a start point and two directions, I think. So direction 1, direction 2. So we have a start point, and then we have a segment start point. So start point is the actual starting point represented by like a floating point position, while segment start is the actual vertex position. So we want this position to be locked to the grid, and that's why we do this one. And when I see this, we can probably skip this one. So I'm thinking of doing, let's see, yeah, let's do this. I don't think we need a failsafe anymore, so current point is equal to start point. And then we just do one check here. While coordinate check for current point. Yeah, we want to include an error as well. So basically what we do here, coordinate check. Did I screw up? Oh yeah. Coordinate checks that the current point don't have the same x and z coordinate. And that's because when we come to the end of an octant, the coordinate for the x and z are the same. So that's when we want to skip one, like the iteration of this algorithm. And then we want to draw a sphere at that position, and then we want to calculate the next point, and we're going to use this function. So I guess it's this part of the algorithm that is actually the important part, or the most important. It's what calculates the next point we should move to, and it does it by minimizing a radius error. So we're gonna do current point, get next point from current point, and then we have direction 1 and direction 2. And these ones, the directions here, are way more important than I initially thought. Hopefully I can show you what I mean. So let's just do, I think we can remove all of this now. Let's save this one. Okay. Gotanod, thank you so much for the follow. So basically we want to do draw octant for, let's do it line by line. So we're going to choose a start point now. I think when they describe the algorithm here, they choose the starting point to be here. So Z0 and X radius. So we're going to do draw octant. Start point is new vector 3. And then we want to do it like new vector 3 math f round radius times delta. Okay. Zero 0.0 and 0.0. When it comes to the directions here, so if we start here and we move, then we can choose two directions, up or down. So let's pick up first of all. And in this algorithm, they refer to something as the fast direction. So that is the direction that changes most frequently. And if we start here and we move upwards, that is the Z. So the Z coordinate changes more often than the X coordinate, and it can be seen here like we move 3 steps upwards, so in Z, before we move upwards and then 1 step to the left. So that's the fast direction, and I'm going to have a slow direction. So for this one, we want to move upwards, so let's do new vector 3, and we always move in delta. So delta is basically our distance between pixels, one would say. It's distance between vertices. If we would be implementing this solution for pixels, delta would just be 1, okay? And what we're doing here could just be replaced by a mathf round. So taking a float value and changing it to an integer value. But we're not working with pixels, we're working with a float grid. So we do it like this and this instead. This. So direction 1 should be, let's see, we need both directions are going to involve the fast direction, so that was upwards in the Z direction. So we can start by 0.0, 0.0 and delta. Positive direction upwards, and then the less speedy direction is 1 step to the left and 1 step upwards. So to the left is minus delta, 0.0 and delta. I think this is what we want. So what this call should draw is this octant, the yellow one, in this very nice GIF here. Let's try it. A little bit afraid, as always, with this while here. Don't want it to go on forever, but I don't think it should. So coordinate check. We take the point, we take the x coordinate minus the z coordinate, absolute value. If that one is less than error, then we return true. And we want to quit here. So as long as this one doesn't return true, we continue. Let's try it. Okay, a little bit worried about this. Very worried, actually. Did I screw up? I don't think I did, but I probably did. I think both this one, and this one are correct. We set current point to be equal to start point here. We coordinate check current point. We change current point here. Get next point. Yeah, I don't know. Okay, 1 sec. Yeah. Let's opt for the angle check instead of the coordinate check. I think that one should be more secure. Although I'm still very interested in what I did wrong here. Okay, so let's replace this one by, and actually I'm still afraid of forever loops. So let's go float t, or actually int t is equal to 0, while and t is less than 20. T++. Good morning, Ferda. So now this one shouldn't be a forever loop, right? T is equal to 0, we add 1 to it, and we only do this while t is less than 20. Okay, but still, let's change this to an angle check. I don't think... Yeah. Let's do angle check instead. So when we do an angle check, it's basically, let's see here. Then we want to check the angle between the start point and the current point. And if that angle is less than 45 degrees, we want to continue. Still circling around? Yes, indeed. So angle check, we do start point, current point, and 45.0. Let's see. So if the angle between those two are less than limit, this one returns true, and that's where when we want to continue. Yeah, let's do it like this instead. And we have this failsafe as well. Start point, current point. Okay, so we do while it's less than 45 degrees currently, and that's why we're also getting this point. So we're actually at exactly at 45 degrees, but we continue. Yeah. So now when we have one octate working, we can probably do this as well. So we start from the other way. So I'm talking about this octate. So It's the same starting point at this as this one, but minus. And we still want to go upwards, but we want to go in a positive direction on the x-axis. Okay, and next I guess we start from this position and this position, but we would go downwards. So we can take this one, same starting position, but we do minus delta, and we take this one and do this exact same thing, just adding a minus here. And then finally we have this one, this one, this one, and this one. And we don't want to go... I guess we want to check not 45 here, but a value that is a little bit smaller, so we don't get this point twice. Because if we do, let's just change this to 44 first, and let's see which points we don't include. Okay. A little bit surprised by that one, but so if we go 1, yeah, 45 is actually here. So if we had a radius of never mind, my first statement was wrong. We don't include the 45 degree. But if we would do angle check and we do this, we will. But it will only be visible at certain radius. Here we go, for instance. So this point would be included twice if we also go in this direction. Something to keep in mind, but we're gonna put it at less than for now, and we're gonna do 45 degrees here, and then let's add the last ones. So let's take this one, and we do so that's upward, and let's see here. Directions, very important. The difference between this starting point, this and this starting point compared to these two are that we also change the which axis is, or which direction is the faster one. So here X changes faster than Z compared to Z changing faster than X, which means that these directions needs to be changed too. And let's start with this one as well. So we're gonna have positive X, negative Z. So we do delta, delta, and 0.0 minus. And then we do this one, which would be in the opposite direction. So we're going to the left, and then we copy both of these, and we do start with a negative start value, and we're gonna go in the positive Z direction. This should leave us with a full circle, I hope. Is this actually the best rasterization of this circle. Yeah, maybe it is. Maybe it is. Because we're not including 45 degrees, so I guess we would get this one as well, and then it makes a tiny bit more sense. Or would we get this one? I think we would be. Let's try it. So we do less than or equal to limit. Okay. I really thought we would be but then again, I don't really know how this sphere would be better rasterized than this. And I want to try visual sphere radius 1, 2. Let's go with 1, and let's do 40, 50. Oh yeah, is this because of t becoming less than 100? Or is it? Or what did we... No, less than 20. Yeah, probably. So let's remove the failsafe and hope for the best. Pretty good. So, I guess we could take this result, and then we could, for each row we get the minimum in the x direction and the maximum in the x direction. So then we get a range of points. So we do it for this row, then we get this one and this one. So we get a start index and for how long it is, basically. Then we do the same for the next row. So we get this one as start index and we go, what is it, 12 or something to this one. And then we do that for each row. And that's how we want to and when we have those ranges, we can call set vertex buffer data. So once again, the idea is to do, we loop through the vertices starting with this one to this one and change them all. And then we set vertex buffer data from this index and with a counter of, what is it, 1, 2, 3, 4. And then we go to the next row, which changes all vertices from this one to this one. And then we call this, and on it goes. But like, there's still an overhead left here. So if we take a look at how we actually get all of these points, we get them in a pretty bad way, I would say. So what we would need to do is, first of all, instead of drawing sphere here, we would have to add them to a list. And then when we have that list, we could sort them based on Z coordinates. And when we have that in place, we go through them. Take the first one with this Z coordinate and the last one with this Z coordinate, and on and on. So my question now is, could we alter this algorithm in such a way that it actually produces this data from the get-go, instead of having to doing sort of post-processing? I don't know. Let's see. So, first of all, we always want to parse 2 octants at a time. So first of all, we want to parse this octant, the blue one, and the green one, because then we get the start point and the end point. So basically we're going to parse blue and green. When one changes Z coordinate, we're going to stop that one until the other one changes Z coordinate. And when both of them have changed Z coordinate, then we know the previous row's range. So first of all, we always want to parse these octants in pairs. So blue, green, purple, yellow, pink, orange, and black and red. And I don't know if we gain anything or if we lose anything if we don't order them in the correct, or we order them by Z coordinate. So what I'm talking about here, if we start at this point and we go downwards, then we get them ordered in Z by decreasing Z. But when we get to about here, then we're going to start from this point and then we go in the opposite direction. So we will get them ordered in increasing Z. Or when we get above 45 degrees from the starting point, then we just change the directions until we get to -90 degrees, then we change the direction again until we get to 135 degrees, then we change the direction again, and then we do that until we get to 180. Maybe. And then again, there's actually, if we would compare this to just doing a straight square change. Like, will the algorithm, will the skipped quote-unquote pixels that we don't, like, will the skipped vertices we don't change outweigh the actual time it takes to run through this algorithm? But then again, right now we do it by, if we take a look at get radius error here, we do it in a 1 abs 3 pow plus and minus. I think we can optimize this. If I read it correctly on the Wikipedia site. And also we can cache this one. So this one we only need to calculate once, right? So yeah, there's still some optimizations to be done here. If we notice that we don't gain much. Let's see here. I think it's time to let's see here. Yeah, what we're gonna do is getting affected. Is it affected or affected with an E? Oh well. Vertices and midpoint circle algorithm approach. Because the fact is, okay, so independent on which of these approaches we take to figure out which vertices that are going to get altered, we're actually going to alter the height map in a square-based fashion, and that's basically because we're going to take a brush texture, which is going to be square-sized, and we're going to apply it to the texture on the GPU. But then when we actually change the vertices, we might want to skip changing them all. We will see, we'll see. So I want to try and do draw circle 1 is going to be this approach. Oh, we calculate delta here. And then we do private void draw circle 2. And let's see if we can make, first of all, I want to see if we can start up here and just go through the full half circle, both in this direction and in this direction, in some fashion. Angle check less than equal. So while actually, first of all, I want a start point, and it's going to be this one. While angle check less than point left, start point, and 180, and point right. And I'm a little bit scared once again, so on. And t is less than 100. Until zero, where are you from? I'm from Sweden. And basically what I want to do here is, do we want to have vector 3? So the Z direction best case scenario, the Z direction will always be downwards, so we will always have a negative Z. So we don't want until nice. I'm from Denmark. Oh, nice. Yeah, I'm also from like south of Sweden, so extremely close to Denmark. Love Denmark. So the problem here is, or what we want to do is, we want to represent the offset directions in a nice way. The Z delta is always going to be 0, but not for both of them. So we will either have, let's think about this real quick. What kind of directions will we have? We will start by having always negative Z, but like the problem, the biggest problem I see here, to simplify this one, is that it's very dependent on which is the quicker direction. But then again, I wonder, I do so wonder if it's possible to include because we can see here, so here the quicker direction is X, here the quicker direction is, or another way to look at it is the pixel will always move in the negative Z direction, optionally in the positive X direction. And here you have the opposite, so it will always move in the positive X direction, optionally in the negative Z direction. Could we make this less optimized but still working by just comparing 4 radius errors? So we always have the different approaches it can take. But then again, we're gonna go negative here. So here we always move to the left, optionally down, and when we get to here we always move down, optionally left. But then we get here, we always move down, but optionally right. This is C# right? Yes, it is. I'm developing my game in Unity, so C# is pretty much the way to go. I didn't choose it, it chose me. C# ain't bad though. Yeah, I like it actually. I pretty much have no complaints. No complaints at all. Okay, it is pretty straightforward. I just keep thinking of ways to make it in one swoop, so to speak, instead of involving a lot of if statements and yada yada. Basically, I'm thinking like maybe we should just have all directions. So left, diagonally down left, down, diagonally down right, and then we just compare those four at all times. Maybe? John Thiel, thank you so much for the follow. Appreciate it. Or actually we need to have what is it? 5 directions. So we need 5 directions per... No, we just need 5 directions for them all. Okay, beautiful, beautiful. But yeah, that's not entirely true. I don't think we can do it like that. Because if we allow for all the directions at the same time, then we don't even get a circle anymore. Like this one will probably jump down and to the right. It all depends on like minimizing the error, right? So we need to constrain it by only having 2 directions to choose from. And those 2 directions need to depend on the octet we're in. So we always need to have, let's do it. Let's just write it out for now. So vector 3 left direction 1 is equal to let's put them here as well. Start point is right, like upwards, so we want to go minus delta 0.0 and 0.0. So that's the 2 different directions that the left parsing can take, and then if we go to the right one, we can do delta 0.0. Let's see if like a pattern appears here that we can use to write this in a nicer way, or remove a step or whatever. Right. And then we do we're gonna have to do checks every damn iteration here, and if we're above or below certain limits, we alter these or not. I don't know, it's not a very nice way of doing things. And the more I think about this, the less I actually think we have something to gain from doing this. But whatever, let's try and finish it at least. So actually, can we rotate them? Can you do something with rotating them? Ooh, you can rotate these. So, let me just bring up GIMP here, let's see. But then again, rotation contra... We're still gonna have to double check things, or like if statements, I think. Or like we could start by just rotating them here. Let's see if we can make a nice rotation solution. So we start with 2 directions. Like the difference between these two are always going to be that this one has the opposite sign on the x-axis, so I guess we can work around that in some nice way as well. But like if we take a look at just these two right now, we're gonna have one that is in this direction, and then we're gonna have, okay, I can't draw with that, we're gonna have one that is minus minus, so in this direction. And then when we get to about here, we want to have this direction and downwards. So if we rotate both of these by 45 degrees, we get this and this. So for each 45 degrees, we just rotate them by 45 degrees. because then when we get here, if we rotate them by 45 degrees again, like this one, maybe this exact same thing is stated here somewhere. But whatever, it's a nice feeling figuring something out yourself. So then we rotate them because we want to go this direction, and finally we rotate them once again because we want to go in this direction. And the right side of the circle is the exact same thing, but we rotate minus, or we just invert them basically. Right? Yeah. So yeah. Let's see if we can do it with this one first. So we need to get with the amount we're going to rotate them with. So here we want to rotate them by 0. Here we want to rotate them by, I don't know if it's 45 or minus 45. No, it's 45, I think. And here we want to rotate them 90 degrees, like compared to the first. It's still 45 degrees between these two, but compared to the first. And then we want to rotate them 135 degrees. So 45, 45, 45. And I think we can base this on, so at all times we have the start direction. We also have the current direction. So when we get to about here, when this one is at 45 degrees, more than 45 degrees here, then we want to rotate the directions we go in 45 degrees. So we can just take the angle between these two, or what is the mathematical, you usually go with an alpha, right? So we take the alpha here and we do divide it by 45 and round it, I think. But we want to floor it. Floor. So for the first it will be 0, and when we're past 45 degrees it will be 1. So yeah, I'm thinking of doing something like this. Let's take a look. Unity, rotate, vector. Rotate. It should be vector 3, I think. Rotate, not this one though, but is that actually the only rotate we have? Rotate. Rotate vector 3 around axis, unity. Angle axis, quaternion, unity. Angle axis creates a rotation which rotates angle degrees around axis. And then I guess we want to apply it as well, right? Did we actually have it here? I might have been a bit too quick. Yeah, we just multiply it, right? Beautiful. For rotation around the world axis, can we work with world axes? I don't know if we can do it later on, but maybe. I don't know. But for now, let's do this. So basically what I want to do is, okay, first of all, we want to draw the sphere. Let's just do this with one, with point left first. So point left. Then we want to do draw not draw octant. We want to do get next point, but we want to calculate offset 1 and 2 here. So point left is equal to new, or actually get next point. Point left. And now we want to calculate the offsets, and we want to calculate the offsets based on rotation. But we want to get the angle between start point, float left, or actually let's see, angle point left is the angle between start point and left point. Point left. So this angle is this one, so we want to divide it by 45. It's in degrees, right? Yes. So we can do float rotation multipliers equal to does this one return an int? No. So we want a floor angle point left divided by 45 degrees. And then we do, when we calculate the next point here, the offsets, or the directions I would call it. So here we do quaternion rotate, or angle axis, right? Angle axis. Or we could just do world coordinates. So we do zero rotation multiplier times 45.0 0.0f. So we rotate 45 degrees around y times angle divided by 45. Does that make any sense? I think it does. And here we do left direction 1, and then we want to do the exact same things. We might want to cache this, but not for now. We're probably going to get some errors here. 2. Does this make any sense? Create start point straight up, create point left, which is start point, create two directions. We're going to the left, so minus in X, is that a quick one? Yes it is, minus Z. And then we do calculate the angle between the start point and point left. So we might want to do this. It's basically what we do here as well, but we just compare here, so we can cache it here as well and reuse it. But then we divide this one with 45 and math floor it, and this is our multiplier for here. So we either multiply this one by 0, 1, 2, 3 and so on. And are we rotating it the correct way? I think so. I want to try this. We're lucky we have this failsafe. If I can remember to increment it. So whatever happens now, yeah, we want to call this one as well. Whatever happens now, we will quit after 100 iterations here. Okay. We rotated the wrong direction, right? That's what we're seeing here. Beautiful. Although, what the hell is happening here? Oh, yeah. So, angle check less than, and here we send in 180 degrees. The problem with that is that angle here, this one is unsigned, so it's between 0 and 180. Probably not 180 including. So, yeah. So the question is, what is less than? Let's take a look. Which one do we call? Angle check less than. Let's do... Don't want to do signed. Now we're still gonna have the same problem, I think. So we're gonna go between minus 180 and 180. We're never gonna get 180. We should, however, be able to do angle check less than equal. Let's try and do 175. See if it gets to an end, if it stops running. Okay, beautiful. But now we miss a point. Ooh, how do I want to solve this one? I don't know. Yo, DevSpiers. Hope you had a great stream. And welcome to all the new viewers. We're just sitting here trying to implement a very nice algorithm called midpoint circle algorithm, used to rasterize a circle, pretty much. But we're going to use it to calculate which vertices and which vertices not to alter when we do some terraforming, pretty much. Looks like Dijkstra circle. I don't know what Dijkstra circle is, but maybe. We're having pretty good progress so far. So we have actually implemented the algorithm in its fullness, so to speak. And now we're just trying to implement it in a little bit of a different way, so we get the data we want in the format we want. Oh yeah, that one. I have no idea why everyone does it with sinus cosinus. I don't know. I don't think they do. But so we have the original implementation here where we do each octet by itself, and like, so we basically do, if we compare it to the Wikipedia site here, we do the blue one, then we do the green one, then we do the yellow one, and so on and so on. What I'm trying to do now is I'm trying to start up here and we just do this side in one swoop and this side in one swoop, because what we did, like, we want this data, we basically just care about the min and max point for each row, because that is going to be our indices when we send the information onwards to the mesh on what to change and what not to change, basically. Yeah, and as can be seen here, we're pretty much done with the left side of the circle. You calculate once and then do those numbers with all possible plus and minuses. I don't know exactly what you mean. Possibly. And thank you so much for the follow, appreciate it. The way we do it right now, so like the algorithm itself always relies on, when you do it per octet, you only move, you have a starting point and then you only move in one of two directions. So for this blue octet, you start here and you move either left or diagonally left downwards, right? So, and each octet has its own directions pretty much, or two directions each. And what we're doing now instead is that we start here and then we multiply, like we compare the angle for how long we have moved along this circle, and when the angle is above 45 degrees, we rotate our direction 45 degrees. So that's how we do it instead. I mean, it works. The only problem we have now is we also have a bigger check here that we only want to do this as long as the angle from the starting point and the end point is less than 180 degrees, but our angle never exceeds 180 degrees because like when you get past 180 degrees, it just measures the angle from the other way, you know. But it's not that big of a problem. We should be able to solve it. But I need to just pour a cup of coffee, so 1 sec. Okay, so I guess we... How can we measure this? How can we compare this in a better way that does work? Oh, that's a different algorithm. I thought that's the one without angles and stuff. Okay, yeah, this is for rasterizing a circle. So no sinus or cosinus so far, what I've seen at least. Angle check less than. Point left, start point. What we can check instead is... I think we're gonna check it like... If... Can we do it like that? I was thinking about just checking start point. Like we could just check distance to start point if it's or if our point is this, if this, let's see, if the z coordinate of our current point is equal to the negative of the start point. But that only works if we're at origin. So but okay, then again we can just offset it. So that's one possible way to do it. Or you could do... You can actually maybe like just incrementing the angle at all times, so we get 180. So when we calculate a new point, like this, we just check the angle between point left and previous point left and add it. And then check if the accumulated angle is less than 180, we continue, otherwise we exit. Although I don't know if that's the best. Or actually we have, what do we have? A rotation multiplier, angle point, left divided by 45, rotation multiplier, let's go with accumulated angle. So let's do vector 3 new point left, and then we do float angle, or accumulated angle, and want to do it between point left and new point left. And finally we want to set point left to be equal to new point left. And then we just do while, we change this one to while accumulated angle is less than 180 degrees. Okay, that's the one algorithm I thought. Okay, so it is the algorithm you thought. Oops. Okay, now we get the last point as well. That's beautiful. Although, fuck it, we have some error going on. Let's take a look. Why? Yeah, here we go. Yeah, we have something weird going on. So as soon as we begin rotating, we don't align anymore. Fuck, that's weird. Why is that? Although this one seems to work, so it's always first one aligns, second one doesn't, third one aligns, fourth one doesn't. What the hell is the reason for that? Actually, let's do draw circle 2. Let's call draw circle 1 as well. But for circle 1, I just want to draw the right hand side. So we want to draw the positive deltas, right? So not this one, and not this one, and not this one, I think. Oops, let's see. I thought wrong. Let's see here. This one goes to the. Oh yeah, of course. We want to include. Let's see here. Right down. So we want to include right down. This one. Right down. Why you just don't draw one octant and mirror every point there? It depends on the transform of the circle, I think. We might be having... So right now we have a circle that is exactly at origin. But if we have a circle that is a little bit offset to the right... we might get a difference. Or am I thinking about this wrong? Then you just offset it after. Yeah, maybe. I'm gonna have to think about that if we have any special cases that might screw that up. Okay, let's see here. Actually, I want to do draw circle 1. Let's change. Yeah, we might look into that later, but let's see. Color blue. Okay, is it actually... Now it is 45 degrees we want to rotate, so why doesn't it work? We get a weird delta here. So the blue ones are the correct ones. Dino Chris, at least that's how algorithm works in general. Just quote, should next pixel be same level or bottom? Yeah, maybe. Maybe. Yeah, you might be right. I just... Octate rotation is same as minus x minus y or x minus y, etc. Basically mirroring. I believe you. But why the fuck are we getting this offset? This one is weird. And you won't get any floats, only integers. Well, we want to get floats. I think we're gonna work like, imagine instead of the dots here being pixels, we want them to be like, it's a vertex grid. Okay, so when we rotate rotation multiplier, math F floor, angle point left, divided by 45. Are we getting a weird... Or do we want to do... Now we want to do it here. Okay, so this one, when we try to... like, these are the two directions we can go in from the start. And when we're above 45 degrees, we want to rotate both of these 45 degrees to this one. And that seems to not work. But if all vertices are on a grid, it's the same as having numerated as integers. Yeah, that's true. I'm just saying that when we want to find the points on this grid, we want to find them by float position. And eventually make them into, convert it into an array index. Left direction 1. Why doesn't this rotation work the way I think it would? Math F floor returns the largest integer smaller than or equal to F, yes. And the weirdest part, I think, here is that the first, or actually, yeah, the second rotation doesn't work. We still have a tiny bit of an offset here. That is true. But what if we do we need to normalize this? What is circle 2? The blue circle is the algorithm just straight out drawn octate by octate. The second one, the red one, is me trying to streamline it. So we calculate the stuff we want to know in the order we want to know them, basically. So we want to go from here to here in both directions at the same time. I want to see if I can do... Oh yeah. So when we rotate them, we keep the length of them, but this one is actually longer than this one. So yeah, we get the correct direction, I think, but we get the wrong length. Algorithm does all octets simultaneously. Yeah, I know it's... I know that's originally how it's done, but that's not how we're gonna do it. Like... what we want to use it for, let's see here, let's play and see. So I can show you, I can explain it. We have a terrain here, which consists of a grid of vertices, right? And then we have a marker, a circle marker, and when we hover above this terrain, I want to get all the vertices making up the terrain that is inside of this circle, okay? But I want to get them in such a way, like... I want to get them in such a way, or formatted in such a way, that we basically can divide them into strips, so that we can, in a more optimized way, alter the vertices in the terrain later when we want it. That's pretty much how I would say it. I doubt you will have the same result drawing it and rotating. Only way to force circle to be with all integer speeds. I don't know. I don't know if you're correct about that. I think what we can do is left direction 1. I think we can do let's see. I think, if I remember correctly, I think we should have a method like this. All vertices, I mean, just right now they are not precise, but circle 1 works by pixels. Not entirely sure I'm following. We'll see. Like what we could do is we could represent these vectors as The problem we have, the offset we're seeing, is because we rotate it, the length of it remains the same, but we actually want it to, like, the length of this one is delta, but the length of this one is, where's it, delta to the power of 2 plus delta to the power of 2 and square root. It felt like this could work, but this is a little bit of a mistake. But what if? I guess we could do, let's see here. New point left. I guess we could just, extremely unoptimized, but we could work with vertices of length 1, and then we just multiply each non-zero element of the vector with delta, but I don't know. So it would be -1, -1, -1. Then we rotate them. Fuck, I don't think... maybe the rotation approach isn't the best one to go. We could as well... Instead we could just do... we could just do it with if statements here. Yeah, but before I do that, I just need to run AFK real quick, so be right back, 2-3 minutes. Okay, back. Yeah, make it work, optimize later. Yeah, that's a mantra I should work with more often. So let's just do this. Angle point left, rotation multiplier. Let's do this, and then we do left direction 1, and we do actually we take this one, put it like this, left direction 1, left direction 2, and then we do this. And here we do a if do we want to check accumulated angle here? Might as well. If it's bigger, if it's less than, let's see here, we want to switch it with at 45 the first time. So we need to do if bigger than 45. But let's do it the opposite way. If bigger than, what is it, 135, then we do this, else if accumulated angle is bigger than 90, then we do this, else if accumulated angle is bigger than 45, then we do this. And what we do is we just switch these for all of them basically. So if it's bigger than 45, we want to go is it this one? So let's see. 0, then we go this way, so it's down to the left or down. If it's 90 degrees, it's this one, it's down or down and to the right. So this, otherwise it's always to the right, but also down, I think. And let's disable circle 1. Okay, great. less than or equal to 180. Will we get this point done? How we get this point? That's very weird, I would say. That's because we need to jump earlier, so doing this check might not be correct either. How do draw circle 1 compared to this one? Yeah, way better. Yeah, maybe I should just rely on this. Maybe it's the best way. What we're interested in actually is, so when we draw this circle, the most important part, or what we want to get from it, is for each row, the first and the last one. But also, then again, if we do it like this, we might get duplicated. Maybe if we do, let's see here, draw octant. Okay, maybe let's go back to draw circle 1 again, and we're gonna do, let's remove these, and we do small dot draw, or actually color is equal to red, yellow, green, blue, and then we do Draw first. I want to avoid like getting the same point marked twice as well. Okay, what did I screw up now? Yeah, but all of them are false. So let's see here. Okay, so yeah, this is how we have them right now. So this one is marked twice, I think, in this case. Let's see. Oh, it's not actually. Oh, yeah. Oh no, did I screw up by doing, let's see here, draw circle 1. If we have a radius of 0, draw octant. Oh, we don't have a failsafe here. Great. That's unfortunate. So on draw gizmos, if radius is bigger than 0.0. Like if we pair these up in a better way, so I think this pair, let's see here, no, this pair and this pair is good. We want to pair these differently. Because we always want to have min-max in the X direction. So let's see here, 1, can I do this now? 1. Okay, none of them draws this one. That's okay for now. So let's change. Let's see here. It's this one is wrong. And what I mean by wrong is here, if we go, now we have like the left and the right side. We have the mirrored octates. Here we have them mirrored by the Z direction, while in this case we have them mirrored by the X. So I think it is first and second. I think we need to do what is it? This one and this one needs to be paired instead. I think. Yeah, and here we have the double point as well. That's not good. So we need to handle that as well. So we skipped this double point, but the first one we get. And it's not as important. I'm okay with the double point when it comes to this starting point. I'm not okay with it here. But okay, let's see. So I wonder if I want to do draw octant. We're going to take this one and we're going to do I'm still a little bit perplexed though that here we do a check that is angle check less than equal. So if it's less than or equal, we return true. And we don't get this one because do we move one more step? Or do we need to check? I want to check here debug.log. I want to log what kind of angle we get here. Angle between, what is it, start point and current point. Oh yeah. $45. Yeah, that's what we get for all of them. So every time we get to here, we have an angle of 45, but angle check less than equal limit. So is that a floating precision error? I want to check. Like it should be equal to limit, right? 45, and we set the limit to 45. So what's up, Norin Dev? Yeah, I'm doing fine. Still trying to get this circle algorithm to work. Properly work for our case, our use case. How about you? Okay, I want to try one thing here. I want to check. We get the angle and then we do private bool float check. Float f1, float f2, float error. Return so let's check this angle. So I want to check float check. Let's just do float check. A 45.0 and with an error of 0.0. Oh yeah. We want to change it here. False. Yeah, okay. So we pretty much compare them, and if we do float error is 0.001. Also false. I edited the wrong one again. Actually, while we do this, let's comment this one out. I'm good. I posted 2 videos yesterday. Oh, nice. What's this algorithm for? It's for selecting. We want to alter the terrain, but we only want to alter the vertices within a sphere. So it's an algorithm for figuring out which vertices are within a sphere, basically. So this is true. Like we're at like it's a floating point issue, I guess. So we want to draw octant, and then we want to do draw octant soft. And in let's see here. In draw octant, we're not going to use angle check less than equal. We're going to do float check. Actually, that's not entirely true. For terrain editing tool, we're gonna actually, in this game, the player and the character will be able to edit the terrain during runtime, basically. So the gameplay will feature terraforming, and that's the part we're trying to implement right now. Okay, we actually want to check less than or equal. So maybe let's just draw octant soft. Let's do so let's do if this one is true, return true. Otherwise, actually we do it like this. Return true, otherwise return float angle is equal to so we calculate the angle. If it's less or equal to limit, we return true. If it's not, we just do a second double check, where we do a float check, basically. Return float check, just to make sure. So we have angle check less than equal and angle check less than, and draw octant soft, or maybe soft isn't the best name. But here we just check angle check less than. Harder check, softer check. Yeah, I think this is going to be very cool when we have it in place. Okay, let's see. So I just need to figure out as well. I want this one to be the first, this one to be the second, this one to be the third, and this one to be the fourth. Now we got this point at least, but we get it twice. Yeah, we get it twice. Third is first, second is second. This one should be third and this should be fourth. Okay, so first och third should flip. First third. So first, third, or second, third, fourth. Okay, I don't really care about... No, I don't think. That for this one we go from here downwards, from this one we go from here upwards. I don't care about that, I don't think. Okay, next step we want to... Yeah, we don't want like double points here. I think we have double points here. We also have it here, but this one we'll have to solve in a different way. So we can see double points there and there. And it's these two we want to fix first. So let's do draw octant soft. It's the second one and the third one we want to change. So instead of draw octant, we want to do soft. Hopefully this will be enough to remove this duplication. I think so. Okay, so here it works. This point is only marked by red right now. Beautiful. And this point is hopefully only marked by blue. Yes. Okay. Next step is to remove the duplication of this one, which means that one of the yellow or the green one is going to have to let go of this point, which means that we're not going to draw the first point, only the second. So let's see here. But I want to see here, draw octant. Basically, let's see here, the start point, I think we can do it like this. So it's one of these needs to start one later. So I think we're gonna do, and we know this might only be true for the we want to check. I was thinking first that we could just offset the start point, but then the first check here is gonna fail. Like, there will exist some cases where we wrongfully mark a vertex. So I guess we could do vector 3 initial offset is equal to, can we do vector3.0? Is it, it's not a compile time constant. Fuck it, let's just do it like this then. Initial offset, and we do start point plus initial offset. And for draw second, okay, for draw third we do, for draw second we do vector3.0 as the offset. Okay. And for draw third we do an offset of, so draw third is we start in z is equal to 0 and x is equal to radius or minus radius. So that means that we will be going downwards, like this is the fastest direction, or what they call it. So we just do new vector3, okay, 0.0, 0.0 and minus delta. So we just jump downwards one step before we start drawing it. I think that will be enough. So yellow get this one, green should not get it. So let's see. Beautiful. Okay, now we don't have any duplicated points. I hope this still stands if we make, Jesus, yeah, this is a problem. So here we probably don't want to do the green ones at all. I thought doing it this way would remove this kind of result, because let's take a look. We do an offset, current point, draw octant soft, we do start point plus initial offset, current point. What the fuck? Why? So what if we don't have the initial offset here? Do we get a similar result? No, we don't. We should be doing this check before we continue onwards, so I have no idea. Did I screw up? Oh yeah, because it's not... Okay, we probably want to do this instead then. So instead of sending in a specific offset, we send in, okay, this, I think this is better. So draw octant soft and we send in bool skip initial is equal to false by default. So we do current point is equal to start point. If skip initial is true, then we do current point is equal to get next point. So draw third, draw octant soft. We can do this for this one, and here we just do false. True. Great. So what if we go even... Oh no, did I screw it up again? This is like the third time today. So we're having a radius that is very small but not 0. It should be okay. Maybe not. Do we want radius to be above delta? Otherwise we don't do anything. Okay, but the good thing about this is we now have, I wouldn't say, we have methods for getting the min and max point on each row, or we have a prelude of methods that gets us the first and last point. That's what we have. So we're gonna have to alter these a tiny bit to return. Let's see. Yeah, we're gonna implement 2 new methods. I wonder if yeah, so basically what we want to check here is we want to check, or from current point we want to save the previous said position, and if said position changes, then we want to store that one into an array. Right now we're going to do it like this. There exists a possible way, note, probably possible to mirror, or actually not research but explore solution explore let's do mirroring. Let's just keep it simple. Oh yeah. So right now we check if radius is bigger than delta before we actually calculate delta. So and then we want to draw them all. Okay. So now what I would like to do is, we would like to do all of this, but I would also like to mark this one, I don't know, as black, this one as black, this one as black, this one as black. So basically for each row we want to mark the first one and the last one as black. Should be easy enough. I'm a little bit afraid though, like I'm trying to visualize a case where or actually before we do it, I want to be able to offset this sphere as well. Then we're gonna do that thing, and then we might as well also explore a way of mirroring points, so we just do it in one direction and then we just mirror the points. But yeah, that would be very nice if that was possible. Should be. Let's implement offset first and then that one. I'm just gonna run FK real quick, like 1 minute. Okay, back. Let's offset this bad boy. Yeah. Can we do... So, draw sphere. No, we don't want to start with 0. We want to do, or we want to start at visual sphere offset, and then we just draw these segments. Yeah, we just have radius here. Okay, let's do visual spheres radius. and grid settings. Circle settings. Radius 1 visual. Let's just call it offset then. Oh no, we can't. What am I using? Yeah, let's call this one offset, and this one we call. Before we do it, we call this one visual sphere offset. Okay, draw circle 1. We need to work with offset here. And I'm pretty sure it's this one, but let's do vector 3. I think we want to do it like this. Start position is equal to new vector 3 what is it? Offset plus delta times vector 3 right. Not delta, but radius. But then we also want to do divided by delta times delta. Can we do it like this? So we calculate the real position, and then we make it stick to the grid. Yeah, let's see. Oh no. Did I screw it up again? Jesus. Let's see. Why did I do it this time? Radius. Ooh, did we rename something we shouldn't? Offset is vector 3, 0. Damn it, let me just fix this once again. I'm sorry about this. Although I am a little bit... How did the introduction of offset here screw us over? Let's see, start position, current point. It's probably... Oh, yeah, right, it's X. Yeah, and then we move in the wrong directions. Okay, before we continue, let's add fail safes here again. Okay, do we have any errors now? Yeah, okay, so visual sphere radius 0.01, 2. Okay, the offset here is a little bit screwed up. Why is that? We have an offset of 0, 0, 0. Yeah, okay, so the calculation of yeah, we want to do math F round as well. First of all, I think this one should be forward. So let's try that. Okay. And then we have this issue. So we want to do a math F round, which means, let's see here. Okay, let's do start position. Start position is equal to offset plus vector 3 dot forward, and then we do start position is equal to okay, guess we can do math F dot round start position dot X Y Z divided by delta multiplied by delta. Oh yeah, we want to divide it by delta within the math round, and then we're okay. Okay, so let's move the multiply to here, remove this one. Because we want to do Y and Z as well. This has to be it. So if we offset this one in the Z direction, what do we get? Jesus, that's not good. So start position is offset plus radius forward, and then we take each element here and we We divide it by delta, then round it, then multiply by delta. This has to be it. Interesting result. Unfortunately, so having 0, 0, 0 here works. Okay, the problem is probably that we don't do anything with the offset here. Could that be it? Start point. Actually, current point is equal to start point. This one is offsetted. That should be okay. Get radius error. How segment point. Yeah, we need to include offset here, I think. Or yeah, we do. Is it segment point minus offset dot x and segment point z minus offset z? Is that the correct way to do it? What's up, Fabic? I'm doing good. Just still fighting against this midpoint circle algorithm. How about you? Thanks for asking, by the way. Very cool. Let's see. Okay, great. I think it works for red. Worried about this though. Or am I? Ooh, yes, this doesn't look good. We need to include this offset. So first of all, I think we need to include it in get radius error, which we do. But then again, segment point minus offset. I'm just gonna move back a little bit. I need to be a bit slower here. So if we offset everything by a vector 3, we draw circle 1. We need to change the start position. That's true. And I think this is the correct way to do it. Then we do draw octant. Current point is equal to start point, so that's including offset. Then we have angle check less than equal. This is just start point and current point, so I don't think we need to offset this one because both of these are offsetted. But then we have draw sphere at current point. This one is offsetted, so it should be okay. Get next point, however. So we're back at this one. Oh, actually, let's just check. What did I do? Did I think, is this the correct way to do it? I thought it was. Seems to work semi good unless like, I'm pretty sure I'm getting this one wrong. So do we want to do minus? Do we just want to do Is it minus? Okay, so each point of the circle can be expressed as x0 plus x. Circle radius error width offsetted circle. What the hell? Oh damn, Fabic, 6 AM. Did you have another productive night? Wow, this is not at all what I want. I'm a little bit perplexed here why. Let's see here. So this is true. For a point on the circle, right? Let's see here. Circle equation. Do we have a wiki? Equation of a circle. Thank you. In an xy cartesian, the circle with center coordinates a, b, and radius r. Okay, so this one. This is exactly what I did. Okay, so that is right. Let's see, let's double check. I did minus, do we want, yeah, minus a. So minus offset dot x and minus offset dot set. I think this is what I did. Yeah, it is. So why are we getting this weird result here? Did I forget to fix it somewhere else? Fabric, sorry for distracting you, but have you thought about calculating only 1/4 of the circuit because the rest is just mirrored of that quarter? Yeah, we actually had someone say the same thing, and yes, that's probably what we're gonna do later on. Or let's see here. Yeah, something of the sort at least. Okay, now let's see why. Let's just see what happens if we do the same thing on all of them. Back. And here we want to do, let's see, is it right? I think so. Yeah, if in the end, like only calculating 1/4 of it in the end, if we can do that, that would be amazing. And hopefully that's what we will converge towards. I'm wondering, yeah. Okay. What did I screw up here? Offset plus radius. We have forward, back. Right. Left. What? Offset should probably rename this center, but yeah, whatever. Okay, so let's start with draw fourth. This one is the... Ooh, I screwed up this. Okay, that's probably it. Draw second should be vector 3 right. Draw third should be vector 3 left. And this one should be back. Almost. Ooh, that's not true though. Let's see. Or is it? Yeah, not entirely. Let's see here. Draw second is this one. So start is to the left. Yeah, this one doesn't share the start position. That sucks. So we want to do... So I guess we could do, let's see here. First of all, draw second is yellow, that is the left one, that's correct. And then we do start position. For this one is okay, for the other one we do... Whoa, 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 whoa. Oh, I do want to simplify this so much by mirroring. Yeah, I think we can optimize this quite a lot after, but let's see. Start position we do to the left. I'm a little bit worried about these offsets. Why are both upwards? That doesn't seem... Is that the correct way to do it? Minus left, draw second. Or did I screw something up? Shouldn't one of these be... Oh yeah, I remember. So, ooh, yeah, this is rough. What we want to do is start position. Let's see here. We move upwards, so this one needs to be plus 2.0 times radius. times vector 3 dot right. What's up, Peach? What in this world is this? What in the world is this sorcery? Yeah, I'm starting to question it as well. Okay, and then we don't have the correct. Yeah, of course. So this one should be right. This one should be left. And now we should have the correct one. Yeah. Like, it being possible to survive on 4 to 6 hours of sleep, that is a superpower, to be honest. I'm one of those people that probably need like 9 hours. And some days I'm barely functioning on that. And then we want to go left here. And we want to do right here. Oh, almost. How did I screw this one up? Third. Yeah, do we want to do right and left here as well? Okay, great. I'm still not entirely sure. Okay, this is actually very nice. This is insane. But yeah, ooh, this is wrong though. The fuck? Yeah, we have a little bit of a weird offset there. And it's for, yeah, so the left one, I think, is it the start position? Draw second, draw third, and it's this one, 2 times radius. Oh yeah, because we want to do 2 times radius divided by delta. Mathf.round multiplied by delta, I guess. Yeah, I'm gonna be honest, like, this is currently a mess, but we're slowly converging towards the correct result, at least. No, Peach, this is just CPU code. A little. Ooh, 1 sec here. Do we have a value where .5? Yeah, and here we're fucked again. Fuck me. I wonder if I can make it possible to post links in YouTube chat. Maybe I should look into it. Okay, this is not good. Hmm. Oh, I don't. Trying to make fractal shapes, yeah, one could think. Smack my peach, what's the end result? The end result is pretty much this, but we want to be able to offset it as well. So this is the end result, but we want to be able to do it in independent on the origin. For some reason, I'm just doing mistake after mistake after mistake today, but hey, sometimes you have those days, right? It's not just me. So the start position here seems to be fucked. Oh yeah. Is it because of this one? This one is wrong though, but I wonder if it's just because of this one, or if I'm doing something else that is wrong. I don't even know if this one is. Okay, that looks pretty cool. But that's not what I want. One thing. Ooh. Ooh. Maybe. Nah, I don't get it. So offset here is, let's change the name to origin. Radius origin. Draw first. We do origin plus radius forward. So that's basically upwards. So that's our start position. But that's in floating point space basically, and then we want to snap it to the grid, and that we do that by doing this. Yeah, we do that by doing this. So we take each position, divide it by delta, round it, and then we multiply it. Although, I think that's how we should do it. And okay. So when we do get next, when we get the radius error here, yeah, we might want to snap this origin as well. Definitely. So origin x here should be, I think, times delta mathf dot round. So in the end we probably want to calculate this once. Origin, divide by delta, then round, then multiply. Divide by delta, multiply by delta. Right? I'm pretty sure. Or now I'm worried. Do we? I want to try it, but I'm trying to make it up in my head. Is it? No. Yeah, I think we want to use the what is the term for it? Whatever. I think we want to do this here as well for origin. Although, yeah, I'm pretty sure. Okay, let's just worry about one of the octates, or we can actually do, let's just worry about two of the first octates. So that's one. Like, if we can figure out why this doesn't work, we should be golden. So we get a problem there, we get a problem there. Is it the problem with negative values? Okay, as soon as the origin is 0, we're okay, we're golden. So let's see, draw circle 1, draw first. Start position is origin plus radius forward, so that's upwards. And then we want to truncate it to the grid. So we take each position here and we divide it by delta, where delta is the length between each grid element. And then we round it, and we do it for x, y, and z, and then we multiply it by delta. And that's the way we want to do it, right? Then we do draw octant with start position here. Delta, delta, okay. Draw octant. Current point is equal to start point. We have this safe check, whatever. Angle check less than equal. Here we compare start point and current point. Both of these are like they are the same the first time, but both of them are offsetted already, so we don't need to think about that in here, I don't think. Or do we? Nah. Or... Yes. Yes, we might need to. So both of these are offsetted. Yeah, I think we probably need to. So we want to do offset between let's do private vector 3 origin truncated. Origin truncated is equal to, and we basically want to do this. I think. I don't know. I'm very skeptical to pretty much everything I do right now, but is that... Oops, we don't want to change that one. Okay, that should be it, right? What a mess. Let's see if it works for the other ones as well. And I also wonder, will it lead to any issues if we use the truncated origin here? Like if we calculate the offset, truncate it, and then add it to truncated origin. I don't know. I don't know. But okay, let's see. Okay, how great. We finally have the marker in place. Great. With an offset origin. But I think that's good. And then, like, it would be amazing. I don't see... Thank you, Fabic. Appreciate it. Like, I'm trying to think about a case where, like, could this circle be located in such a way that we can't simply mirror, like if we just calculate this one and then just mirror it and mirror it. It should be okay, right? But do we have some weird offset? Nah, like if one side changes, all of them changes, right? Ooh. Here it doesn't though. What the hell happened there? Yes. There will be some edge cases when you are at the border of the whole terrain because you won't have the whole circle. Oh, that's true. We need to keep that in mind as well. But check this out. This is quite interesting, isn't it? Oops. So if we have an offset of 0.05 in the Z direction, we don't get the same result down here as up here. But actually that's something wrong with my algorithm. It must be, because my implementation, because yeah, I have done something wrong here. Because if we check this sphere here, we shouldn't get, if we're at this point we should be moving here, not here. And if we're at this point we should be moving here, not here. So yeah, I fucked up. So we can probably calculate these points. But we need to check something, because this one is also wrong, I think. How the hell did I manage to screw up this badly? Yeah, okay, so it's probably using the angle check less. This code is a mess now as well. That sucks. Yeah, I'm pretty sure I have screwed up somewhere, and I think it has to do with where we truncate the origin and where we don't, where we truncate the radius and where we don't. But I'm gonna have to take care of this, or we are gonna have to take care of this tomorrow, because unfortunately it's that time again. I need to run. But good point is, hopefully it won't take too long tomorrow, and then we can hopefully get some terraforming working. Yeah, I know. Unfortunately, it's gonna be like this in April. I have some other things I need to do. Peach, yes I can. I can leave you the Wikipedia link. I think I linked it. Let's see. So you're talking about this one, I hope. Thank you, Fabic. And let's see here. In real life, yeah, real life side quests sucks indeed. Thank you for watching. So, thank you all for watching. As always, we'll be back tomorrow. Hopefully with some terraforming. Have a great rest of the day. Peace.